Vectors and scalars. A brief intro. Why should you care? Vectors and scalars are both important in physics. They allow us to talk about different quantities in different ways. And actually, you know more than you think you do. So what's the difference? Both vectors and scalars assign a numeric value to something, some quantity. But vectors have a direction too. And vectors get special notation. For example, x with an arrow over it would be a vector. That little arrow is how we're going to note when something is a vector. Okay, so let's talk about distance and displacement, which we talked about in class today. Distance is just a number, although with a unit. So it's the odometer in your car or how far you run during a workout. There's no direction involved, so we call this a scalar. Displacement has a direction. It's how far and in which direction you are from where you started. It's a vector. So a few basic math ideas. A scalar you can add or subtract only with another scalar with the same units. To multiply or divide, you can multiply or divide with either another scalar or with a vector. So this is kind of like when we had a scale factor in geometry, hence the name. For a vector, you could add or subtract only with another vector with the same units. To multiply or divide, you can either multiply with a scalar, like we've talked about, or with another vector. Now, there's two different ways to multiply vectors with each other. We'll get to that much later in the course. For adding vectors, for now, we're just going to talk about parallel and perpendicular. The result that we get when we add them is called the resultant vector. Okay, if I'm adding parallel vectors, okay, they put them in the same direction, tip to tail, and the magnitudes just add. The picture down on the bottom left, vector A plus vector B, all right. So that one's not really to scale, but you can see that the resultant is in the same direction as both of them, okay? So if they're in opposite directions, really what this is if one is negative, right? So this would be the same as subtracting parallel vectors. So we would put them tail to tail, and then the larger magnitude determines the direction. So in this case, the one shown, you take the value of B minus the value of A, okay? And because B was the longer one, the direction is going to be in B, but it's the magnitude of B minus that magnitude of A, okay? Again, this picture is not quite to scale. Okay, what about if they're perpendicular? This is where we get a little tricky. If we're adding them, we put them tip to tail again, okay? So here you have A plus B, and it doesn't matter which way you go, right? Addition doesn't matter the order. So I can take A plus B, shown on the top route, or B plus A, shown in the bottom route. Either way, the magnitude is A plus B, that purple line, all right? And as you can see, that's a right triangle if those are perpendicular. Therefore, the magnitude is determined by the Pythagorean theorem, right? So the length of that is the square root of A squared plus B squared. Okay, now if you want to subtract them, here you have A minus B. So you put them tail to tail, all right, which is really the same as calling B the negative direction of what it would have been, okay? And so now the magnitude, it's still determined by the Pythagorean theorem, but it's in a different direction, okay? We're not going to worry about the angle at which one of these is when we add them when they're perpendicular. We'll get to that later, okay? So you'll see an example in a second. All right, a cyclist rides 3 kilometers west and then turns around and rides 4 kilometers east. This is a slight variation on the one we saw in class. Okay. The distance, it's a scalar, so I just add up my magnitudes. So 3 kilometers plus 4 kilometers equals 7 kilometers. Okay, we should be comfortable with that one. All right, the displacement, however, is a vector, and in this case, east and west are anti-parallel, okay? Or it's a subtraction problem, whichever way you like to think of it. So 3 kilometers minus 4 kilometers is minus 1 kilometers west, or you could say 1 kilometer east. Okay, let's try this when they're perpendicular. A cyclist rides 3 kilometers west and then turns around and rides 4 kilometers north. All right, to find the distance, it's again a scalar. 3 kilometers plus 4 kilometers equals 7 kilometers. The displacement is now adding 2 perpendicular vectors. Now, I purposely picked the numbers 3 and 4 because then you get a Pythagorean triple. So 3 kilometers west plus 4 kilometers north equals 5 kilometers in a northwest-ish direction. Like I said, we're not really going to do the angles here, so for right now, northwest would be the right way to say this. If you have any questions, all right, please refer back to the vector unit in OpenStax, which is in section 2.2, or CMIS Cardinal for any extra questions.